Yesterday I did a video using a large MOSFET and showing you how you can drive a motor just by simply putting some charge on the gate. Here I have my finger on the positive terminal, and if I move my hand over to the negative terminal I can turn off the MOSFET. And this is fun to play with, but now we really need to do something that's going to be more interesting. So this is what we originally had here. I left the gate open, and by touching the gate and touching the positive terminal of the battery we can turn the MOSFET on, and by touching the gate and touching the ground we can turn it off. What we want to do next is hook it up to something like an Arduino. So what I did is I produced a program on this Arduino, and it's really just the fade program that's available in the examples in the Arduino. So I wrote the program. The fade program causes an LED to fade on and off very gradually. And so what we're going to do here is fade the motor on and off instead. And we're using the MOSFET to drive the motor since the Arduino can't do it by itself. What I did is I changed the fade rate from 30 milliseconds, the fade delay from 30 milliseconds to 100 milliseconds. So because it would be much too fast for the motor to react if we used a lower fade delay. So when you do this yourself, use the fade program and just change the delays to 100 milliseconds for this. Now to hook this up, I want to draw power from the battery, from this 12-volt battery, and some people aren't aware of how to do this. If you look at the Arduino, you have a input on the Arduino called VN right here, and right next to it there's two grounds. So we're going to use that VN to give power to the Arduino. There's two ways to get power into the Arduino. You can either use the coax connector here and hook it up to 12 volts, or you can use this VN connection, which is really the same connection. And this allows you to use an unregulated power supply to drive the Arduino, and it's safe to go up to about 12 volts with this. You wouldn't want to go too much higher than that. So I'm going to take this positive voltage, I'm using a red wire here on VN. I'm going to hook this up to the positive terminal of the battery, like so. Like so. Then I'm going to hook up ground. Right next to VN is a ground terminal, and we're going to use black to designate that as being ground, and we're going to hook that to the negative terminal of the battery. And immediately, if everything's okay, your Arduino should light up. You should have power to it. Be careful, because if you hook something up backwards or you don't hook it up to the right pins, if you were to hook this into the 5 volts for instance, you would instantly destroy your Arduino board. So be very careful. It's got to be VN and not 5 volts. The regulator on the Arduino board converts this 12 volts into 5 volts, and you can get 5 volts off your 5 volt input, but you cannot hook 12 volts into the 5 volts. So just be careful of that. Now this program is designed to drive pin 9 in PWM mode, so I'm going to plug this white wire into pin 9, and I'm going to hook this up to the gate on my MOSFET here, and we should immediately have this thing working. So if you notice, you hear it whining, it ramps up, gets to full speed, starts to ramp back down again, and it just continually ramps up and down. The hookup that we currently have is like this. So we went from basically this with an open gate to this where we've just got pin 9 of our Arduino hooked to the MOSFET gate. We've got the ground of the Arduino hooked to the negative 9 volt terminal of the battery, and we've got VN hooked to the positive terminal of the battery. By the way, your power supply can be anything you have around. It can be an actual plug-in power supply, a car battery, a small 12-volt battery used for children's toys, whatever you've got. I recommend having a 12-volt battery around because they come in really handy for high current experiments. Now, we could hook an external device like a potentiometer or something to this so that we could vary the ramp up and down speed. So that might be a topic for the next video. I just thought the fade program would be an interesting way to drive the motor. And one thing you need to always think about when you're looking at all these different example programs in the Arduino is, what if you were to use a different type of output as opposed to the one that they originally wrote the program for? There are lots and lots of possibilities doing this. Now, one reason why you can hear a sound when the motor is turning is because when we're operating in PWM mode, we're actually sending a frequency, a certain frequency to the motor, and the width, what we call the duty cycle of that frequency, is changing. In other words, the on time initially, when the motor is essentially off, the on time is 0. And little by little, the on time is made longer and longer and longer, and the off time is made shorter and shorter and shorter. And this has the effect of making the motor go faster and faster and faster. And of course, if you left the motor, if you left the output pin completely on, you would be at full speed. And then it does just the opposite, ramping back down again. The on time becomes shorter and shorter and shorter, and the off time becomes longer and longer and longer until it's completely off all the time. And this is the nature of PWM. The motor doesn't know any different than if you were to change the voltage to the motor. But if we were changing the voltage to the motor, the problem we would be having is this MOSFET would be getting really warm. Right now we're not really asking much of the MOSFET because all we're asking it to do is turn on and off. There's a little bit of a period of time that it takes the MOSFET to charge up and a little bit of time that it takes to lose that charge. And so sometimes if you're driving a really high powered device, you need something to help quickly get the charge into and out of the MOSFET quickly, and there are ICs that let you do that. So this didn't take very long. You could do this yourself in your lab. Just be very careful. I don't want anybody burning out their Arduino. But this is part one of many different things you can do with a MOSFET, a motor, or some other high power device in your Arduino. Hope you enjoyed it. Let me know if you've got any ideas for things you'd like to see on the channel.